Today we're starting integrals. We already know about integrals. We've already taken these parts of the notes. Integral is just the area of a region. We denote it as a to b of dx. A and b are the limits. A is the lower limit, b is the upper limit. D of x is called the integrand. We already went through Riemann sums. The left sum, the right sum, and the midpoint sums. All right, looking back at this problem, what was the left sum for f of x equals x squared from your notes? What was the left sum from your notes? $2.625. What was the right? 4.125. And what was the midpoint? 2.812. 5, whatever, 9 So all the Riemann sums gave us a different answer. It all depended on where I placed my rectangles. This is the integral of the same exact thing. I have the integral from -1 to 2 of x squared of dx. To solve integrals for integration, the dx part is that's the derivative of x squared. So we have to take the antiderivative. We're not done with antiderivatives. Antiderivatives are the rest of the year. Antiderivatives will be the rest of the year out. What's the antiderivative of x squared? X cubed over 3. From -1 to 2. That line, it just gets rid of the integral symbol. We took the antiderivative. That gets rid of it. Yeah, and that's what you get here. And it's normally a plus c. And that's the one part of antiderivatives you didn't like, is the plus c. Now, the nice thing about integrals, it doesn't matter what the c is. What's the nicest c to work with? Nicer than 1. 0, which means it's not there. You don't need a c. C is just 0. It can be any of the antiderivatives. What we want to do is find out what's the difference between 2, bless you, and -1. So here's what we're going to do. We're going to take 2 cubed over 3. You take the upper limit minus, yeah, it's a big giant line. Yep. All I'm doing is substitute in that number. The upper limit minus the lower limit. It's always minus in between. What's 2 cubed? 8. 8/3. What's -1 cubed? -1. What's -1? +1. So what's 8/3 plus 1/3? 9/3, which is 3. What this means, if I take and graph f of x equals x squared. The area under the graph from negative 1 to 2. So if I take this and I graph it from negative 1 to 2, and I graph that, all of this right here would add up to 3. It is an exact answer. With Riemann sums, they're all approximations. The reason why some of the rectangles went over, some of them went under. Riemann sums give you an estimation. Integrals are the exacts. Doesn't have to be a whole number. But you mean just a number? Yeah. Yes. If I have a number here and a number here, yes. You can get negative numbers. There are going to be occasions where you have like x up here. Okay, how's that going to change the problem? This one would become x cubed. Can I do x cubed over 3? No, x cubed over 3. What's this right here? Plus 1/3. Done. I can't do anything with it because there was a variable in the problem. Right. She said it was just any old number. I was making sure she understood that I'm saying it doesn't have to be a whole number. All right. If there's 2 numbers here, you should get 2 numbers here, which would mean you get a number as an answer. Here's this one. Take the antiderivative. We don't care about the c because it could be any antiderivative. I have the integral of 4x cubed from 2 to 5. All I have to do, take the antiderivative of 4x cubed, which some of you do it this way. I don't even care about the constant or the coefficient. X to the 4th, because I just raised the exponent by 1. Take that, put it on the bottom. Put the coefficient back. What's 4 over 4? 1. So it's just x to the 4th from 5 to 2, or from 2 to 5. Do you see what I did? You take the antiderivative. Once you take the antiderivative, you now need to take it from the points 2 to 5. So I just take 5 to the 4th minus 2 to the 4th, and man, is my board on the line. Derivative. You're taking the derivative in respect to x. All right, 5 to the 4th, 625. 2 to the 4th, 16. 625 minus 16, 609 is my answer. So the area underneath 4x cubed from 2 to 5. That's just where I put it. I can't see it. That's not really helping me too much either. There. I'm not going to get the whole graph, but everything that's underneath here, the area would add up to 609 whatever units. 609 units squared. You're fine. You can just write 609. There's no catch on this part right now. This builds on one another. These are just the basic antiderivatives that we worked on. It gets more in depth. Let's do one part at a time. Try this problem. When I take the antiderivative, what's the antiderivative of negative 3? Negative 3x. I need to take it from 1 to 4, which means negative 3 times 4 minus negative 3 times 1. 3 times 4 is 12, negative 12. What's negative? Negative 3 and 1. Plus 3, which gives me negative 9. Now, the one thing I don't like about that all right, there's my graph. That means the area is negative 9. Can you have a negative area? No. Technically the area is 9. Just because the line's underneath, that's why I gave you a negative. We will get into some cases where I have a graph and it crosses. There's my graph. And it goes like this. You have an area right here, and you have an area right here. So you just can't take the entire area. You have to do a piece here and a piece here. Integration by parts. You'll notice ahead of time. We'll get into this. Try this one. If everyone opens your book to page I3. Open your books to page I3. On page I3, the top of it has all of the differential. All right, on page I3, here's just a list of some derivatives. If you forget some of them, like the derivative of sine gets me cosine. So if I take the antiderivative of cosine, it gets me sine. So you look backwards to get the antiderivatives. On the bottom part, you have some integration rules. Yeah. These are some rules we will use. No, we will not get to all of them. All right, a lot of these we will not get to. A lot of these are basic ones. And I will give you a list of other ones. So looking back to the derivative of cosine. The derivative of cosine, or antiderivative of cosine, is sine. So I have sine from pi over 2 and 0. Sine of pi over 2 minus the sine of 0. Now, you can look at your wheel real quick, or you can put it in your calculator. Pi over 2, sine is 1. At 0, sine is 0. 1 minus 0 is 1. And that's your answer. Are you okay with basic integrals?